Today, we are going to have fun with algorithms. That's the topic of today. Today's topic is fun with algorithms. Hello there. So, I will take you a couple of steps back. Actually, I mean, you already know these concepts and some of the things that I will mention today. I will take you a couple of steps, remind you what algorithm is, remind you the details of algorithm, and then slowly take you back to our main topic, Python, and talk about Python functions. So this will be what I will be doing today. First, let's go a couple of steps back and remind you what algorithms are, which you already know, but I will just remind you. And as I said, I'll just take you slowly forward to today's topic. So what's an algorithm? There's an input, there's an output, and there's something in between, which we call algorithm. And it's composed of a set of rules to obtain the expected output from the given input. This is a very rough definition of algorithms. And here is some very simple idea of what algorithm is. You want to eat a sandwich, but this is what you see when you open the fridge. Full disappointment. Then computational thinking, of course, having taken this class, you are not just going to go to the market and do your shopping and come back and make a sandwich. You will think computationally, right, to solve a problem, because that's the skill that you have acquired in this class. So as a computational thinking expert, you will just divide the problem into 4 major parts: problem decomposition, data abstraction, pattern recognition, and algorithm design. And you will think like this. So in the problem decomposition step, oh, you cannot hear anything. They say they cannot hear anything.
Can hear, Hocam.
Oh, they hear, okay. So, but just Idil cannot hear. Idil, maybe it's about your laptop, probably. So as a computational thinker, you will divide the problem into 4 major parts, and this is how you are going to analyze this issue. In the problem decomposition step, you divide the problem into sub-problems. And as you can see on the screen, where's the pointer? As you can see here, these are the sub-problems that we have to solve in order to make a sandwich. We should solve the problem of a round trip to the supermarket, acquiring the right ingredients, and making the sandwich. These are our sub-problems, and we will have further issues regarding the sub-problems. In the data abstraction aspect or step, we have relevant data and we exclude unnecessary data. We are not interested in what brand of cars are on the street right then when we are trying to make a sandwich, or we are not interested in what show is running on television right then. We are just interested in the right data that we want to focus on, and it's this data. Only the route to supermarket, not elsewhere, and only the sandwich materials. This is the data we need to be able to make a sandwich when our fridge just has one stupid piece of lemon inside. In the third aspect, we have pattern recognition. Pattern recognition requires us, this step or this aspect requires us to find out patterns in our problem. If we can recognize patterns, we do not have to repeat, we do not have to find a new solution for every step. We can just repeat certain patterns, certain solutions to certain patterns. That's why we need this step, pattern recognition. So walking somewhere is a pattern. So I don't need, I mean, this is of course a very simple and stupid example, but this should give you the idea of how we approach much larger and complex problems. I do not have to find out how I can walk to the supermarket and walk back separately. I can just find out how I walk somewhere or how I reach somewhere. And that pattern will be useful when I'm going to the supermarket and when I'm walking back home. Buying something, the pattern of buying something will be sufficient to understand how I buy one piece of material and another piece of material. I don't need to find different procedures for buying these different pieces of materials. And making a sandwich will be one of the patterns that I will need. So, I mean, you have already excelled on these previous steps until now. This is the 12th week of this course. You are already experts on the first 3 steps. Now you are excelling on the 4th step, algorithm design, which requires determining the necessary steps of making a sandwich in this example. This is roughly what we are going to do. First, you get out of the house, walk towards the supermarket, find the right alleys and find the right products, then walk back home. Actually, these are the same pictures, but it should be different directions. Then come home, prepare the ingredients, make the sandwich and enjoy it. These are roughly the steps that you should be following. And if you just turn it into plain language, you walk to the supermarket, you buy ingredients, you walk back home, you prepare ingredients, and you enjoy the food. So why are these simple steps interesting for us? It will be interesting from this point on. So this is roughly the algorithm that we are following. these are the steps that we are following when we are preparing our sandwich. We prepare a shopping list, we walk to the supermarket, we buy the ingredients, we walk back home, then we prepare the sandwich ingredients and we enjoy the sandwich. So there are a couple of things to notice in this simple algorithm. This might look very simple, and it is actually. It's simple and straightforward, but just notice a couple of things. Notice the resemblance between steps 2 and 4. Look at steps 2 and 4. In the step 2, you walk to the supermarket, but again, in step 4, you again walk back home. So there is something similar in those steps. There's a pattern of walking, just the destination is different. This idea of finding the pattern will be helpful for us to understand Python functions, and actually any function in any coding language, in a sense. It's a similarity here. You walk to the supermarket, then you walk back home. There's something significantly similar going on in these two steps, which is basically finding the direction and taking steps, right? When it comes to walking. The basic structure of these steps are similar. We can reuse the same step with different directions, that is supermarket, home, work, school, etc. You can, if you define walk function, which I will give the details in a minute, you can use that function for every direction that you want to walk to, right? That will be a simple case for us. I'm not giving details about quiz, that will be a surprise. We can reuse the same step with different directions, that is supermarket, home, work, school, etc. We could use, for example, step 3 in another algorithm to buy a particular book. Also here in step 3, we have the buy, I will call it function already. I'm trying to acquaint you with the idea. I'm using the buy function with the ingredients of sandwich here, but in another occasion, I could just buy a particular book. And the procedure would be exactly the same. If I define buy abstractly enough, you go to the right place, you acquire the substance, you go back to the cashiers, you pay for it, and you walk out. If I define it abstractly like this, that substance and that place could be either a bookstore and a book, or a market, or a supermarket and the products in the supermarket. And you can use the same procedure, technically called function, in different occasions, right? I know that these are simple examples. I'm getting to complicated steps slowly. Let me first, if it works, show this video. If it doesn't work, okay, it works. Let me show you this video. It's a small video. It's a short video about. Yep, I share this on about what algorithms are. It's a short video, and then I'll go back to our algorithm.
You may have heard the term algorithm recently, whether it was online or maybe...
Whoops, sorry.
You may have heard the term algorithm recently, whether it was online or maybe in some conversation about technology. It's a word that gets thrown around a lot, but what exactly does it mean? Well, simply put, an algorithm is a set of steps used to complete a specific task. They're the building blocks for programming, and they allow things like computers, smartphones, and websites to function and make decisions. But in addition to being used by technology, a lot of things we do on a daily basis are also similar to algorithms. Let's say you want to make some spaghetti. In order to do this successfully, there's a certain set of steps you need to follow in a particular order. First, you need to boil a pot of water. Once it's boiling, you then add the spaghetti and cook it for a set amount of time, stirring occasionally. Once it's finished, you drain the water and then it's ready to be served with a sauce of your choice. That entire process is actually an algorithm. Because you followed those steps in that order, you reached your desired outcome, a delicious pasta dish. But if you were to make a mistake, say over or undercooking your noodles, it probably wouldn't be as good. Programs work in a similar way. Their code is made up of algorithms telling them what to do. Let's say that we want to use a navigation app to get directions. When we punch in a destination, the app uses an algorithm to look at the various available routes. Next, it uses a different algorithm to check the current traffic. And then a third one takes that information and calculates the best available route. All of these algorithms are built right into the app's code. If there were any kind of error in that code, the app wouldn't be able to follow these algorithms correctly, meaning you wouldn't receive your directions. Both of these examples show how both humans and computers can use algorithms to perform everyday tasks. The difference is that computers can use algorithms and calculate things better, faster, and more efficiently than we can. Technology is only going to continue to evolve and get even better at what it does. As long as coding and programming continue to be used, algorithms will be at the heart of these technologies, guiding what they do and how they do it.
As you've seen, the idea is super simple. The idea of algorithm is super simple, but the difficulty is when it comes to abstracting certain parts of the algorithm. I mean, you're determining steps. As I will show in either one or two slides further, you can define steps in all sorts of details. It could be too abstract to the point that you don't understand anything, or somebody else who reads the code doesn't understand anything, who reads the pseudocode. This is, let me write it here. This is what I was talking about, pseudocode. So we call something pseudocode. You're already, I think, familiar with this term. When it's not the code itself, when it's not the Python code, but it just explains the steps in sufficient details. You can either write the pseudocode, these sufficient details, in too abstract a form that nobody will understand what's going on, or in too much detail that people will just get lost in those steps. So the right amount is the difficult thing that we have to find. I mean, look at this picture. You can see all sorts of car parts shown in explicit form here. Even in here, some parts are not explicit. Even the details of the engine are not explicit here. So you could even go further details to find out the exact pistons and all sorts of parts of the engine, or you could just close this lid for good and just go to the steering wheel and talk about how to drive a car rather than how the engine and all these specific parts function when you drive the car. So the amount of detail is related to what you are interested in. If you are interested in fixing this car, then of course you have to talk about these details when the car is running or when the car is not running. But if you're just interested in running the car, driving the car, you wouldn't be interested in all the details that's running under the hood of the car, right? So if an algorithm is full of details and too long to read, it will be difficult for a human to understand and work on it. To overcome this problem, we need to abstract certain portions of an algorithm. Thanks to abstraction, many people can work on the same project without knowing all the details. Again, the car example, I think, is a good example. When you want to find out driving a car, you just need to start. You need a function like start the engine, either by turning the key or pressing a button. You just need to know you need to start the engine. You do not need to know all the details of what's going on under the hood when you start the engine, if your purpose is just driving the car. So the amount of details or the type of details depends on what kind of purpose you have regarding that particular action. This idea will be useful for us when we are finding the abstraction level of our algorithms. Coming back to the algorithm of making a sandwich. So this was the initial algorithm I have given to you. Prepare the shopping list, walk to the supermarket, buy the ingredients, walk back home, prepare sandwich ingredients, and enjoy sandwich. This seems to be detailed enough to give us an idea of what the necessary steps are, right? But you could have written it in much less details. Acquire the ingredients, prepare the sandwich, enjoy the sandwich. You could have even written it in one sentence, maybe. It all depends on how much detail you need to give, right? But in any case, even if you give less details, at some point you have to specify much more details in order to, for instance, if you want a robot to make the shopping for you, right? If you're programming a robot to do this, you have to give all these details to the robot, even further details, of course, even much more than this. Even this could be something too abstract for a robot. So the amount of details you provide depends on your purpose. If you are giving details just to yourself, you don't even have to give these details, but you are probably just thinking of something like this when you're doing your shopping for buying a sandwich. You could have written something like this for yourself. Prepare a shopping list, leave home, walk to the supermarket. If there are any shopping carts, get a shopping cart. Else, if there are any shopping baskets, in which case there are no carts, get a shopping basket. Then, while there are uncollected items in the shopping list, find the corresponding aisle inside the supermarket, put the item in the cart or basket, whichever one you've taken. go to the cashiers, pay for the items, walk back home, unpack all the ingredients, etc. You could go on with all these details, right? So if you're teaching how to make a shopping either to a kid or a robot, probably you would have to go into either these details or even further details than this one. So the amount of details that you have to go into will depend on the purpose. Who is going to read the algorithm? How many people are going to work on the same project, etc. will all determine the amount of details you need to write in a code. Also, even if you are the only person who is going to read the code, if you write like 200 lines of code, it will be even difficult for you to understand, to follow what you had written there. So you have to abstract certain portions of the code. Even if you're telling yourself to like go to the market and buy ingredients, something like this should be sufficient for you. And when you get to the supermarket, then you can think of details like this, right? Until that point, you do not have to think of all these details. So where am I trying to get at with all these seemingly unnecessary information? Let me take a couple of steps further now. Writing a simple and understandable algorithm should be our aim. There are some advantages of keeping it simple. Anyone who reads the algorithm, including the writer himself or herself, can get the purpose of the algorithm easily. We do not have to deal with filling in all the details from the beginning. So now, this is the point I wanted to get you with all this initial information. Sub-algorithm, the information about sub-algorithm. Sub-algorithm is a general name for functions. Different programming languages have different names for functions. They call them routines, functions. They have some other names. Does anybody know some other names? What do they call functions in other languages? Do you guys know? I think they might also call it method in some languages. In any case, the general name is sub-algorithm. So now we are walking into the territory of sub-algorithms. We are going to understand what sub-algorithms are, and in this idea will help us in Python to write more understandable, more easy to follow codes. Let's go back to our shopping algorithm, sorry. We had this algorithm where second and fourth steps had something similar, the walk function. Only the destination was different. In the second step, we are walking to the supermarket, whereas in the fourth step, we are walking back home, right? So now we have a sub-algorithm with destination as its variable. If you define walk algorithm with destination as its variable, as the name suggests, as the name variable suggests, destination can vary, it can change. You can insert anything in place of destination here. And that's what we have done here. In the second step, we used this sub-algorithm with destination supermarket. And here, in this fourth step, we used the same sub-algorithm with destination home, back home. So sub-algorithm walk could look like something, as something like this. Find the best way to destination, while not at destination, keep taking steps or take steps on the way. We could also do the same thing for the buy function here. I mean, we had this simple algorithm, but we could even further define buy. And you will remember this piece of pseudocode, let me correct myself, piece of pseudocode from a couple of slides back. Look, it was already here. That part here, this part, I just took out this part from this long explanation and wrote it under sub-algorithm buy. If there are any shopping carts, get a shopping cart. Else if means there are no shopping carts. So if you are reading this part, you say if there are any shopping carts, get a shopping cart. And if you come to this point, you know that there are no shopping carts. If there were any shopping carts, you wouldn't read step 2. You don't need to read it. You will just jump to step 3. If you are reading step 2, you know that there are no shopping carts. Else, if there are any shopping baskets, get a shopping basket. And then you come to step 3. While there are uncollected items in the shopping list, first you find the corresponding aisle of the item in the shopping list, then put the item in the cart basket, go to the cashiers, pay for the items. So this whole steps, this 5-step algorithm is a sub-algorithm for our main algorithm. It's the third step. I just took the third step and expanded it here and called that expansion a sub-algorithm. I mean, we will come back to Python code, but this part is really important to understand. It might look simple, but just try to understand the level of abstraction we are going through here. This is good enough for a human being to understand, whereas this one was not good enough for us to understand. This is too complicated. It's not even finished, you see. You need like 5, 6 more steps here, maybe 10 more steps. That's too complicated, unnecessary detail. We need something like this. You're teaching a kid how to go to the supermarket and make the shopping. This is something that you should teach in the beginning, or to a robot. Then when it comes to the details, you will give details in small pieces, right? Using sub-algorithms. Is this too simple, too easy? Let me get a bit faster. Let me get to the Python. Everybody's here for Python, right? Okay. Let me get to the Python step. So this was our walk sub-algorithm. I was using another sub-algorithm here, find the best way to destination. It could be named sub-algorithm 3, find the best way to, and I could even write further details for find the best way to. Find the best way to destination means turn your location service, open Google Maps, enter destination, click on directions, choose the walk option, click start. I mean, assuming that you do not already know the way to the supermarket, etc. I mean, this might be a simple example, but I'm trying to give you the idea that this is your main code, okay? This is your main, in this case, this is your main pseudocode. Here is one sub-algorithm, but even the sub-algorithm can have another sub-algorithm. So we are just abstracting. We are just postponing details to other sub-algorithms. This is how you should be programming. You should not, I don't want to see like, I mean, in this class, we're not going to write 200 lines of code, but in another class, if you are coding at all, nobody wants to see 200 lines of code just written in an unnecessary fashion. If you could write them in a simpler way using functions. Sometimes you need to write 200 lines of code, but most of the time you don't have to. Okay, now Python. Now this is the point everybody was waiting for. A general name for sub-algorithms in programming languages is function. A Python file that stores function is called a module. So finally, Python code here. So this is how we define functions in Python. Let me, again, before starting the Python code, repeat this part. Why do we use functions? First of all, for ease of programming, ease of reading, ease of coding, ease of working together. That's our main purpose. Nobody wants to see like 2,000 lines of code. So this is how you define a function in Python. This might not suggest much, but if you look at here, it will be even more clear. This is how you define a square function, for instance. You have a special word here, def. You define the function. This is the name of the function, square, and this is the variable. It's the counterpart of destination in our walk function, right? For the supermarket example. Then here's another special word. Here's another special word that we use in Python. This is return function. You have to use this. This is not a choice. After you write a function, that you don't have to use a return line, but if you use it, it will be more efficient if you use in a function. Then you write whatever you need to do in the code. So let me go to Trinket now to see what this is doing. Okay. Oh, I've already written it here. Okay. So this is how we write it. I write, is it large enough? Can I, okay, this is it. Daha da mı büyük yapayım? Oh, I'm just sharing the other one. Okay. Let me just stop the share and share this one. Let me just share. Should I share the whole screen? Let me just share the Trinket. Okay. Okay. That's even better. Thank you. So here I have my function. As you can see in the code, this is how you write a function. You use the reserved word, def, and return is another reserved word. These are like built-in words in Python. This is the word of your choice. I just named this function square. I shouldn't use a space here. And there is this column that you have to put after you write the square. And return is again a reserved word. You have to use it. And this function will return. Do you know this sign? Star, star. Do you remember this? Yeah, to the power. This is x to the power 2, right? I could have written it like this. Since it's square, I could have just written x times x. So now since this is our main program, I can just call square function by writing square open parentheses, give me a number. So, and so if I run it like this, what will happen? What will you see? What will you see here on the right-hand side?
25.
Do you want to see 25? Do you think you'll see 25 on the right-hand side when you run it like this?
Maybe we should write the fourth square.
Print, okay. Without writing print, you will not see anything there. Actually, let me show you. Let me just run it. So now it's running, and it's done. It has calculated the result. Just hasn't told you anything. So where do I write print? Can I write print? Where should I write print?
You can write
What's the difference between using the variable x or just square? So Hassan, if you write just square and without anything in the parentheses, oh, where should I look for Hassan? Okay, I should look at the camera. Hassan, if you just write square without using anything in the parentheses, you are not giving a variable to the function. Okay, thank you, Damla. Damla has written the great explanation there. So if you don't write anything here, and in that case you cannot use x inside because you haven't defined x, this wouldn't make any sense. So if you use x here, then you call it with 5 in the main function, x will become 5 and it will return 5 times 5. And as what's your name again? Aksan. As Aksan was saying, we need a print function here in order to see the result of our calculation. Okay, now, are we missing anything or should it work now?
Yeah, it is going to work.
Yeah, okay. Good, it's now working. This was easy, huh? Let's write a cube function. Give me the lines. How do I write a cube? I'm going to take the cube. I'm going to write a function that takes the cube of one integer. Make me write it.
Cube. Again, x. Enter.
Column. Don't forget to do this.
Yeah.
It took me some time to learn the column, yeah. And return
x to x.
star
To star 3.
3. Okay, how do I use it?
Again, we should use print function.
Can I just copy? Doesn't let me copy. Let me write it. Print.
This cube and whatever you want.
What's your number?
9.
Yeah.
9.
9. Sorry. Is it correct?
Actually correct.
Yeah. Okay. So, any questions regarding this? What have we done until now? We could have done this without using functions. This is just a simple step. We are getting acquainted with functions. We are getting used to functions. This is nothing complicated yet. Yeah. So there is nothing complicated yet. It will get more complicated. So I mean, even if we had written these functions without using, even if we had written this code even without using any functions, it wouldn't take too much of lines. As I said, one of the purposes of using functions, one of the major purposes of using functions is simplicity of reading, ease of coding, etc. We are not there yet, right? These are simple steps, but we are learning how to use functions. So let's keep using functions. Let's turn this code into let's turn this into a code which takes numbers from the users, which asks users numbers, and we will write the numbers here on the right-hand side.
Input, integer.
Do you start with input?
Yeah.
You want to cast it to integer?
Yes.
And?
Actually, we can use float.
Say it again?
We can use float too.
You want to use float?
Integer.
You want integer?
Yep.
Okay. So what do you write inside the parentheses?
Please write.
Do I use
Yeah,
quotes?
you have to use.
Which quotes do I have to use? Double quotes or single quotes?
They are same.
They're same?
Yeah,
Quote works? Good. Please enter a number. Is this good? Is this gonna work?
No, it's not going to work. You have to write another functions or another function for this program, and we have to click other.
We want to get rid of these print functions,
Yeah.
but the definitions will stay, right? Because we are going. That's our purpose. We want to use these functions.
Yes, they can.
These definitions will stay here.
Understand.
We just want to modify this code in a way that the program will get the numbers from the user. We will not write it inside the code. I want it to ask the numbers here, and I want to enter a number there, right? So we are on the right track. We will use input function, but I think we need some detail here. How do we proceed? Who is speaking? Okay. Where do I write the variable?
First, x equals integer equals.
X equals, where's my equals? Like this.
I think we should reverse integer and inputs, but I'm not sure it makes a difference.
So you want to take the input first and then cast it to integer. Is that?
Then one, yeah.
This is what you want me to do, right?
Yeah.
What does this line do? What have you done here? There are multiple commands. So is anyone reading the chat screen? I think Damla is writing answers to the chat, right? Oh, she already written. Okay, good. Somebody's checking the chat in the meanwhile. Okay. What have we done here with this line? You were the one who's saying this.
Yeah.
So what's this line doing?
I want a number, then the string comes down, it just takes that into a number as well.
Does everybody understand what he's saying? I think this is trivial, but it's an important step. He said, if you wouldn't put this int part, this would just get a string. So these are different variable types. So what he's saying is this. I mean, this might be too trivial for some of you, but I wanted to remind this. String is usually a word. It could be one character, but it is usually a word or a sentence. That's what we call string in programming languages, right? Int is an integer. We have another one. Sorry. Oops. Float. Float is a floating point number. How would you describe it in a better way? A number with a dot in it or a comma in it, right? Ondalık sayı. So if you just use the input function, like x equals input, please enter a number, it will get the number as a string. What's the drawback? Why wouldn't I use a string? What's the bad thing about using a string? What's the problem with taking a string? Can I not do this? Oops.
You cannot do mathematical functions with
So do you think this will not work?
no.
It will give an error? Okay, let's see.
It won't multiply, it just prints.
So first it asks the number. Until that point, there are no errors, right? It's asking the number. I'm giving 6. And it gave an error, you're right. And the error is unsupported operand types for star or power string and integer. You guys follow here? Let me just make it larger. I mean, part of coding is understanding the errors. It's probably the most important part of coding. We call it debugging. You might have already heard of this word. So there's a problem in the code. It's giving the error, and now you have to debug the code. This is the word I'm using. You should get the code. You should get rid of the bugs in the code. Insects. There are insects in the code. I mean, do you know where this word is coming from? In the olden times, computers were the size of this room, and there were cards being entered into computers. There was this error that people couldn't find the reason of. in the end, there was a bug inside the computer, actual bug. This is where this term is coming from. You need to debug the computer. You need to get rid of insects out of the machine. So you see the error here. This is the error. Reading and understanding errors is one very crucial step of any type of coding. Here, what does the error say? Unsupported operand types for star star or power, string, and integer. And this is exactly what your friends were saying. Delete this word. When you code cube, it also gives me the line number. In line 5 cube, return star star. I mean, usually you read error lines starting from the bottom, because usually you'll find the stopping point at the bottom. It says there's a type error here. It explains the type error, and just one step up, it gives where exactly the problem occurred. Line 5 in cube. You go to line 5. When it was trying to calculate this operation, make this operation, it encountered a problem. It was using a string in a mathematical operation, just exactly you were saying, right? You cannot use a word in mathematical operation. It was, I mean, trying to take cube of a string tree was trying to do something like this. My name star star tree. It had the similar effect of this. As you can see, this has no meaning, right? You cannot take the cube of my name. In a similar sense, if you're trying to take the cube of tree as a string, not as an integer, it doesn't work. Is this an easy trivial point for you guys? I mean, just try to understand that when you are inputting a number, you have to write this at the beginning. In order to cast, this is the technical word I'm using here. In order to cast it into an integer. Turn it into an integer. I mean, you don't have to know all these technical words. Right, so that's why we are writing int here, to turn it into an integer. Okay, so is it going to work now?
No. You have to write print function.
Great. Because if I start it like this, if I run it like this, it might be calculating something, but it will not give me the result. I don't know what it's doing, right? I will just write print here. Print parentheses cube x. You can just say maybe cube of the number is, how should I, what should I put here, right here in between? Comma? Both work. Okay, let's try. What's the number? 12? Somebody said 12? I just heard 12, I don't know. Seems to work. I mean, we don't have the chance of checking it, but it's probably true. Let's give a simple number. So it's working, yeah. Is this okay until this point? This is like Python functions 101. This is the simplest step in writing Python functions. I want everybody to understand this piece of code at least, because you will get to more difficult steps in the remaining of this class and in your assignments as well. Please make sure you understand these steps. There are multiple comments in chat. I think Damla is writing answers to everybody. Okay. I cannot read all of it now, but if there's anything that's not clear in the chat, I mean, Damla is already like helping you, but if you want to speak, you can also try to speak as well. Yep, thanks, Damla. So, I mean, among those, there's a question. It doesn't matter. So it doesn't matter to define a function before the input, right? Okay, what do the others think? So somebody asks, let me see who is asking that. Irem is asking, can we define functions after the print here? Could I just delete the cube function and write it here? Could I do that? Any guesses? I think there's some there. People have started saying no in the chat. it wouldn't work. Why wouldn't it work? Okay, I don't have to try. Why wouldn't it work? Have you tried before?
Kusai said, hocam.
Say it again.
Kusai said that because Python reads from top to bottom, said Kusai.
Simple and clear answer. Sorry, I couldn't just make it any larger. Because Python reads from top to bottom. Because Python is interpreted, the technical explanation is Python is interpreted, not compiled. But if these terms are like strange to you, foreign to you, you don't have to follow the technical explanation. Kusai has given the easy to understand explanation. Did you understand the answer to that question? You cannot write definition under print because Python code hasn't come to that level yet. It doesn't know what cube is. And before explaining what cube is, you are asking it to take cube of 3 or cube of x, right? That's why it doesn't work.
This is great function first, and second, he isn't going to see because he saw print and program stuff.
Right, yeah, that's the answer to the question. Okay. Any other questions regarding what functions are doing, how we write functions, why the heck we are learning functions? Any other questions about functions? Let's get a bit into more details. So let me just share my screen so that when I switch things, you just follow what's going on. So this was the slide that we were discussing. We have done the exercise. Write the function. Look at the bottom of the slide. It says write the function for taking the cube of a number entered by the user. We have done that step now. We are here already. Let's look at this slide. This is the function for taking the right power of a number, x to the power y. Now things will get a bit dirty here. Let's go on. This is the function. I can actually probably just copy the function. Can I copy the function? I think I will be able to copy. Yep. Oops. Oh. It will take a second, but I will manage. Yep. Copy. Let me go to here. Yep. And paste it here. Where is my paste? Here. So let's look at this code now. Is it large enough? This is the code for taking the power of a number. The function takes two variables, x and y, and it finds as a result x to the power y. So if x is 2 and y is 4, the result will be 8, right? It takes 2 to the power 4. Not 8, 16. So that's what the function is supposed to do. And let's look at the code now. How did you write the code? Writing something like this line, result becomes x, that line requires some experience. I mean, without having experience about how to write this type of codes, you might not directly understand why we started with a weird line like this. But it will be natural to you after writing, starting to write your own functions. Let's look at this part. For the time being, let's forget this line. Let's disregard this line. Result becomes x. Let's look at this line. What is this line doing? There's this range function, this interesting range function. For I in range 1 to y, it will calculate something. But let someone explain to me what this line is doing. For I in range 1 to y, what does it mean? Do you remember for loop? We may have two types of loops, for and while loops. And this is one type of loop that we love using in all sorts of coding languages, programming languages. What's this line doing?
We got answers in the chat, hocam. If you want, I can read them.
Let me just read the chat. Technically, we can print not that one, sorry. Hocam, there are no answers here.
From Kusai and Doğasel, hocam.
The result is another variable for I is a loop.
Doğasel said 1, 2, 3.
Oh, okay, that's the final answer. Okay, 1, 2, 3 until y minus 1. Do you guys understand what's happening there?
Yes.
Can you say it with your words?
If we say y is 5, our function will give us 1, 2, 3, and 4.
Right.
It will not give us 5.
It will, sorry, go ahead.
Because Python doesn't give last number, doesn't count last number.
I mean, it's true. Let me make a small correction there. It's not like it's false, but let me just tell it in another way. It will just repeat whatever comes after 4 this many times, right? Whatever comes after 4, actually there's extra indentation here. Whatever comes after 4 will be repeated as many times as this range function is defining. Range function is giving us. And here in this example, as you were saying, if y is 5, it will do it 4 times. Whatever comes after 4 will be done 4 times, right? This is what the range function is doing. It will start counting from 1, it will stop at y minus 1, and it will do whatever is written here that many times. So here we are calculating, we are first writing result, then result is assigned to result times x. For how many times is this calculation being done? Y minus 1 times. So if x were 2 and y were 4, this would be calculated 3 times. Let's try to imagine what's happening here. X is 2, y is 4. Result is assigned to 2. Then for 3 times, it will calculate this function. Result will become 2 times x plus 2, 2. So result becomes 4. This was the first time that for function is run. For loop is run. In the second run, result is 4. Result becomes 4 times x is still 2. So result has become 8. So I'll just show 8 like this. This was the second step of second time the loop is running, for loop is running. It will just run one more time, right? That's it. And in the last time, result was 8. 8 times 2, it will become 16. And it will not go back to here. It will just get out to this step. And it will return 16. Let me now visualize what I've just said. I think you guys are used to using Python Tutor. Let me visualize this in Python Tutor. Oops. Okay. So this is our function, right? This is our function that takes power of, oops, sorry. Private tab, okay. And I want to take power with power of, or should I say it, 2 to the power 4. This is how I want to call the function. So now let's visualize what's happening here. Visualize execution. Okay. So now we are starting. I will press next and it will just start. So we have here, it's just the first time the function is encountered in the program. It's calling it with 2 and 4. If you look at here, x became 2 and y became 4. 2 is assigned to x, 4 is assigned to y. Because of the previous step, because of this step. In this step, we are calling power with 2 and 4, right? So now, since power is called in the main function, it's entering the power function, and it will first assign result the value of x, so result becomes 2. Then it enters the for loop. I, in the first run of the loop, is 1. It will calculate result becomes result times x line. Result became 4. Let me go back one step. This was the first time we entered the for loop. Result is multiplied by x. You can see the numbers here. Result was 2. It multiplied 2 with 2 and it became 4. The second, now it will enter the for loop for a second time. Now we are entering to the loop for a second time. Result is again multiplied by x. As you can see, the value of x never changes, whereas the result is always changing, right? And this is the last time we enter the for loop because I is 3 here. And since y is 4, as you can see here, range function always goes until until y minus 1 in this case. So it will just calculate it one more time, and this time you see the red arrow is still at 4 at the line with for loop, but it will not enter for loop. It just skipped to 5. Look, one step back. At this step, red arrow is at step 3, but it knows that I is 3. It checks this condition. I is not in that range anymore. So it's just skipping step 4 and going to step 1. See? And it's returning the result. Return value is 16. We didn't write print here, but we don't have to write print because we are just visualizing the code anyways. Okay? Any questions until this point? I mean, I understand that this might be too easy for some and too difficult for others. So you can ask any kind of questions that you're thinking of. Don't hesitate to ask any questions. Okay, let me check the chat. Why do I need I? Why? Okay, somebody says, why do I need I? Could I have written this for loop in a different way without I? I couldn't because I need something like I. Look at these steps. How do I go back to that step? Oh, first step. Okay, let me just start again. I need something that counts the steps for me. How many times the for loop is run? So that's why I think Mohammed, was it Mohammed who is asking the question? Yeah, Mohammed. The reason you need I is you need some variable that counts the number of times you go into the for loop. And as you can see, I is incremented by 1 at each step for loop is run. Now it will become 3, and then it will just stay as 3 and until the function is ending. I mean, use this website for yourself. It just makes it very easy to understand the inner workings of these functions. Python tutor, it's really helpful. Any other questions? There's no definition for I. Well, Python is interesting. You don't need to define a variable as integer or something else. You just use it and it understands it by itself, what kind of a variable you are using. So here, yep.
Sorry, Hocam. A student said, can you run it again and explain?
Sure. Let me quickly run it again.
Thank you, Hocam.
Go back to the first step. So now we are in the first step. Python, okay, we are just running the code. Python sees the def, the word def, and it just skips until step 7, as you can see, because if you see def, it just means you will come back to this if the function is called. You don't have to run all these lines until 5 until the function is called. That's how you're seeing inside the brain of Python interpreter actually right now. This is where I start from the scratch. I press next, and Python just skips def, the word def, because it will just come back to the function if it's called. If it's not called, it doesn't have to go through all these steps. In line 7, it's called for. Now it's calling power with variables 2 and 4. When I call with variables 2 and 4, x and y are already assigned these numbers. You see the definition of power is written with x and y as variables, and I call it with x and y as these values. So these values are directly assigned to x and y here. Okay. X becomes 2, y becomes 4. Now we are going into the function because it's already called for. First, we define something called result, a variable called result, and assign result the value of x. I mean, you are already familiar with the idea that equal sign doesn't mean equals. It means assigned is assigned or becomes. So here you read this line as result becomes x, or result is assigned x, not result equals x, okay? So result is assigned the value of x, which is 2 in this case. Now we are coming to the for loop. This line determines how many times for loop will be run. It defines an integer with the name I, and it assigns it the value 1. It assigns the value 1 to integer I because of range function. Range function says assign 1 to I and run this code, run this for loop until I is y minus 1 in this case. Okay, and each time for loop is run, Python will increase I by 1. We'll add 1 to I. So in the first step, let me go back one step. This is the first time for loop is running. Result becomes result times x. Now look at the result, it's 2. After I press next, it will become 4, right? Simple. Second time the for loop is running, I became 2, result becomes 8. Third time it's running, where do I know that it's the third time? Because I became 3. Now result will become 16. Now since I is already 3, it has reached its range, it has completed its function. Now it's jumping to step 5. Sorry, line 5. And it will return the result, which is 16. If we had written print here before power, it would have printed it. Okay. Any other questions? Okay, chat is clean, class is clean. Let me go on. Should I go on or should I just slow down here? How is it going on? Good. Normal pace. Okay, let me just go on in the same pace. No faster, no slower. Here's an exercise. Write the function for taking the white power of x both entered by the user. Let's do this. Let's do this exercise. Exercise. Write the function for the white power of x both entered by the user. Let me go to Trinket and let's write this together. So we have this main. We can just keep square and cube. They can just stay there. We don't have to delete them. But we might have to delete these parts. We don't need these parts anymore. We need a code that will write, okay, I think I can keep this one. We need a code that will take 2 integers from the user and print out the first integer as the base and the second integer as the power. I've already given you the first line. X becomes int input, please enter a number. At this point, everybody in this class should understand what this line is doing. If you don't understand, let me explain it again. Please ask me if this line is clear. The line explaining how you take an input from the user and turn the value into an integer. That line is, this line will be probably with you until the end of this class. That's a simple line, but we will do such calculations all the time. You take something from the user, you might be turning it into integer, or maybe not, depending on what kind of function you will be running, okay? Are there any questions in chat? You already have the function. Somebody says, please explain again. let me just do this step. Let me not go back at this point. So we are supposed to take 2 numbers from the user. This is the first line. Actually, let me just say, please enter number 1. And I take that number as x. X becomes integer input, please enter number 1. This line takes a number from the user and assigns that number to x. How do I get the second number? How do I get the second number? Who is gonna tell?
Y is input, please enter a second number.
Y equals, exact same thing, right? For stylistic reasons, let me just use space here. So I'm just doing the exact same trick as before. Input. Please enter number 2. Okay, I'm missing a parenthesis here. Do you see that I'm missing a parenthesis in the first line? When I go next to the parentheses, it just shows me the coupling parentheses so in a small square. So there are no coupling parentheses for this one, which means I need another parenthesis there. Okay, I've taken the numbers. What else? What now? Print. Somebody said print. Yep. Who said print? I heard some print from there. Yep. Go ahead. What do you want to print? You want to call the function, right? You want to call this function, power function. And the only way to call a function is call it by name. You have to write power. And how do you call a function? You look at the definition of the function here. It needs two variables, you see. So you should call it by the way it wants you to call it. It wants you to call it with two variables, x and y. So that's what you need to do, power xy. I think this should give us the result, right? Do you agree? If we haven't missed anything, let's run it. What's number one?
2.
3. What's number 2? 4. What's the result you're expecting? Good. Good job.
Sure, what happens if you write print result?
Here. What do you expect?
Same thing.
Okay, this is interesting. You are getting into the boundaries of another issue, scope of a variable. I'm expecting a error here. Let's see what's happening. Name result is not defined. So the problem is, okay, this is an advanced issue, a bit advanced, not totally advanced, but a bit advanced issue. This is the problem. I mean, it says the result is not defined, but you think like you defined result. Why doesn't it understand what's happening here? Because you defined result inside power. So the scope, this is a technical term, the scope of result is only within the function power. When you get outside the power, it doesn't recognize result. Result is someone just inside that function, some variable just inside that function. And you get out, the Python interpreter does not know who result is. That's the idea.
That isn't the result.
Yep. Is that, say it again?
That isn't the result outside of.
You're right, yeah. What would happen if I did something like this? Sorry.
You have to define the result.
What would this function give me? What would happen now? What would it print?
6.
Not 81?
6.
Even if I give 3 as the base and 4 as the power, you are saying that it will give me 6 and not 81. Huh?
Yes.
True. Yeah. Because of the scope issue. Again, you don't have to deal with all these interesting issues, but now that somebody has asked, I mean, you have asked, so that's what will happen. Okay. I'm deleting this. And I'm deleting this. Plus power xy. What would happen if I write 2, 3 here? But even then, what would be the result be if I write 3 and 4 here? So if I press enter, what will be the result? 81? No? Because I'm calling with 2 and 3, right? Here I'm calling power with 2 and 3 and not with the numbers that I take from the user. It's clear, right? Good. It will give 8, not 81. All right. Good. So these are simple for you guys. Let's get a bit into more complicated issues. Any questions until this point? Okay. Any questions in the class? Good. Let's go on. So, I mean, the algorithms that we have written until this point, cube, square, x to the power y, etc. These are rather simple algorithms. They will be useful for writing further algorithms, more complicated algorithms, but by themselves, they are not that complicated. Here we have sorting algorithms that do real that are the real deal. These are the real deal. In a sorting algorithm, I remember this from Sabri Hoca's class. You guys were like holding numbers and just swapping places, etc. That's how, for instance, bubble sort is working. In a sorting algorithm, you have something that can be sorted. In this case, it's numbers. You could have like words there. It could have been a dictionary, for instance. But in this case, you have numbers. You run the sorting algorithm, and you get a sorted list. This is how these algorithms are working. Let's go to this website now. Can I go to the website? I think I can go to the website if I make this, if I present this. No? Oops, okay. Maybe I have to write it then. Oh, it's okay, it worked. So on this website, I need only one. On this website, we have, look at the top, look at this list. It has all these different types of sorts: bubble sort, selection sort, insertion sort, etc. I will give you my handout so that you can just, if you haven't already, I mean, it's a simple name of the website. You can already see it, but you will see my notes as well. You can pick the type of sort that you want to do, and here you can actually write your own list as well. It has already given us a list. So let me just start this algorithm. I think I should click sort here and go. Is that how it functions? Yeah. Now on the right corner here, it's giving you the steps. It's giving you the pseudocode of what's happening. It's a different pseudocode. It says do at the beginning and while at the end. It doesn't matter for our purposes what kind of language this is. It's just running this code until the list is sorting. And since this is bubble sort, remember how bubble sort was functioning. Look at the animation here. It just compares pairs. And if a pair is not in the right order, it just swaps them. Look what happened there again. It's just comparing each pair and swapping them. And when the list is sorted towards the end, it's not checking it anymore. It will stop checking here. It will not go to 46, as you see. So this is how bubble sort was working. It's not a, I mean, all these sorting algorithms are, none of these sorting algorithms are super efficient, but you don't have to worry about efficiency at this point. They are just working. That's important for our purposes. These sorting algorithms do what they're supposed to do. They're just sorting numbers. So let's look at the code of these type of algorithms. Let's play with the functions of sorting algorithms. Is there anything in the chat? Okay, thank you, Dama. So let's go to the code. Okay, this is our code for now. This is the function for bubble sort. I hope you don't find this very difficult. Let's play with this. So let me just get out of here and copy this code. Copy and go here. Let me open a new Trinket. Could I click it? Okay, it's working. Just taking, oh, what did I do? Right. Let me paste it here. Oops. Okay. So this is our bubble sort. I mean, the details of the steps might not be very friendly to you now, but you don't have to understand all the steps for the time being. Just understand how it's working. I mean, most of the coding today is done like this. You know what you're looking for. You find the code somewhere, and you just understand how to read it. Most of the time, you don't write stuff from scratch. I mean, for this class, since this is an introductory class, you will have to write stuff from scratch. But for those of you who will be interested in coding later on, you usually find stuff and you learn to understand reading the code. That's the most important thing. So now here is a code. Let's look through it very quickly and then learn how to use it. It just defines something here. I mean, defines something, defines the name of the function here, defines a function here. The name of the function is bubble sort. It takes one variable. It's supposed to be a list, apparently. You know, this sign shows that there will be a comment after it. It's not run by the program. It says we go through the list as many times as there are elements. Look, there's a problem here, by the way. For starts without indentation. It starts at the same line with the definition of the function. It's a problem for Python. If you run it like this, it will give you an error. Look, for Python, indentation is the most important thing. Look what it says. Expected and indented block. So indentation requires giving some spaces here. Regularly, you have to give 4 spaces, but for our purposes, a tab is as good as 4 spaces. So, and this one has to go back here. So there are problems with the indentation here. You have to check it when using code from somewhere. Sorry. Now the indentations are correct. Let's read this code very quickly. It starts with the def line. It gives the number of the function, bubble sort. It gives the name of the variable it's going to use inside the function, our list. Then it goes into a for loop. For I in range, what does len do?
0, 1, 2, 3. Here's another.
That's what range is doing. What does len do? It takes the length of the list. So if there are 5 elements in the list, I'm not sure if it's going to give 4 or 5. Do you guys know by heart if len is giving the number of elements or number of elements minus 1?
Number of elements.
Number of elements? Okay.
Or it starts, I think, 0.
Right. No, it's not right because it's just giving a number. Len is giving just a number. Range is starting from 0, unless you specify where to start from. Okay, good. So if our list will have 5 elements, len returns 5 in this case, and I will take values 0, 1, 2, 3, 4 until it will assure us that the for loop is running. I have done an indentation error here. It will be running 5 times. Okay. So this is what this line will do. It will take the length of the list and run the for loop length minus 1 times, right? If the length is 5, it will run this for loop 4 times. That's what for loops do. It runs the loop range minus 1 times, or the limit, let me say limit minus 1 times. Then another loop comes, another for loop comes inside the for loop. It uses another variable j, and again it takes the length and subtracts 1 from the length. And since in our example I gave 5 as the number of length, it will become 4. Length is 5, length minus 1 will become 4. So it will be running 3 times. This for loop will be running 3 times. It will runs limit minus 1 times, right? Oh, it will run 4 times. It will, okay. So if length is 5, this number will be 4. So it will be taking values 0, 1, and 3. Okay, it will run 4 times then. Okay, thank you. Then it will come to this point. It will make a comparison between j and j plus 1 values in our list. Since j started from 0, as Typoji was saying, it starts from 0, it will compare the first element, which has the index 0, and the element next to it. And if first element is larger than the second element, it will swap their places. And this is how it's a shortcut of, there are commas and double assignments here. You don't have to deal with those issues right now. Just understand that it's a line that swaps. For our purposes, let's learn to use this function. Again, how do I call a function? I call a function by its name. I write bubble sort, and I have to use the right number of and right type of variables. For our purposes, we need a list here. Let me just give it a name. Let me call it my list. Before calling it with the name my list, I have to specify what my list is here. So now I have to define my list. How do I define a list? I want a list of numbers, square brackets. And how do I write the elements of the list?
Wow.
I just write numbers, right? And use comma in between. Do I not have a comma here? Just random numbers. Let me not make it ordered. Let me just write smaller numbers after larger numbers at certain points. Okay. It is now, let me just click one. Let me have, okay, oh, this is good now. 7 numbers in it. After I call bubble sort, I'm expecting to have a sorted list, numbers in order. Again, if I want to see the list as a result, what should I do here? Print, right? If I run it without print, it will just do something of which I have no idea. I just need print, and don't forget to have the parentheses couples. Are there any mistakes here? I think it's supposed to run in the correct way now. Okay, let's try. It just gave. Oh, thank you. Great. Okay, let me ask you. What should I do now? Typoja was saying I didn't return the list. What does that mean? What should I do? What should I do now? Well, he's giving a great hint here. He said you didn't return the list. How do you return the list? What does he mean? Any answers in the chat? There are no answers.
Use while.
We don't have to change the code. We don't have to change for loops into while loops. The code is correct. But Typoja has given the hint actually. He said you forgot to return the list. Which list he is talking about and what does he mean by return?
You don't reach an answer.
We reach an answer. This code is actually doing what it's supposed to do. It's actually sorting the elements. As the result of this code, our list, whatever is given at the beginning, is a sorted list. When it reaches the end of this line, it's a sorted list now. But each function, not each function, let me correct myself, not each function, but if you want the function to return something, you need this word return here. You need to return something. Our list, yeah. Okay, I think it should function fine now. Because without return, it just gave us the result none. Now it should give us a sorted list. Good job. Any questions about, somebody was asking this code in the chat. I think you'll find this code when I give out the handouts. Something was asking for the code in chat. Okay, there's another discussion going on in the chat. People are discussing what they should return, etc. I don't see any. Were there any questions? Kusai says, I don't know what I should return. There's nothing to return. So, Kusai, the purpose of this sort was to take a list, sort it, and return it back. And then you have to return the list if that's the case, right? That's why we need that line on that's code on line 30, return our list. So let's now modify this code to take input from the user. I'm not giving my list within the code. I want the user to give me the list. How should I start? Again, input. How do I take an input? Well, maybe I should do something before taking input. Let me just leave it to you. Again, the purpose is we have the sorting algorithm. It's already given to us. We only have to write a couple of lines to ask the user to give it a couple of numbers, maybe 4 numbers, 5 numbers, doesn't matter. And then it will just sort and give out the sorted list. It will create a list of those numbers and just give out the sorted list.
My list equals.
Say it again.
My list equals.
What was the first thing you are saying?
My list.
My list. Can you take a list like that? Maybe you can. I'm not sure. Can you take a list like that by using brackets with input? You can do that. Okay, good. Oh, you cannot.
You can create an instance.
And then okay, but then you cannot take a list from the user from in the console, right? I have no idea about how to do that. If it's possible, maybe. But that was your purpose, right? That you were saying you wanted to create a list and you wanted the user to give the whole list. I was imagining the user giving numbers one by one, actually. I wasn't imagining the user to give the whole list. Do you know if you can take a whole list from the user? I didn't try it myself either, so I'm not 100% sure. Let's take numbers one by one. Let's do that part. So now we have an empty list here. My list is an empty list. I want the user to give me one number. How do I take one number from the user? Oh, actually, I want to take a number from the user and I want to assign that number to the first element of the list, as the first element of the list. How do I do this? How do I refer to the first element of the list? Come on, we have 5 minutes. We have to finish this.
That is my list.
My list?
Close brackets, 0.
Great. This is the first element of the list. What does this become? Who was speaking? Were you speaking?
Yeah. Like inputs into your person.
Good job. Enter your first number. Okay, come on. Okay. Okay, whatever. Right. And probably you have to I cannot since copy it here. You can copy this line and write it as many times as you like. Well, there are other ways of doing it, by the way. There are easier ways of doing this. And I will not go over them right now. Let's do this since you mentioned this method. Let's go over this. I will just write this 2 times. Maybe 3 times.
You have a list.
Say it again.
Start with Trinket will have a list. My list is empty. I should change the things inside the list.
Okay, good. So are you saying that, this is a good question. You are saying that if we start with an empty list and refer to the first element,
Yeah, there is no list.
it's not going to work, right?
Yeah.
Okay, let's try what it will do if I run it like this. Actually, just let me write it in a shorter way. Second. What number? I'll just write second. Okay, let me run it like this. And let's find the answer of your question. So its first number is 56, second, right. Index out of range. So this is the exact problem that you were referring to. We haven't defined the first number, so we cannot change it. We could just have given dummy numbers here. Yeah, I didn't want to use it. I don't want to use it right now. Append function.
Should we know that by now?
No, you don't have to know it now. You were supposed to learn it in the labs. But that's fine. Say it again. I just created dummy numbers here, and now we can change the numbers with whatever the user is giving. This again, 56 is the first number. Second number is 2. Our sorted list is how do we know that it sorted our list? Let's first, in the last 2 minutes, modify this. First, give out the unsorted list. Sorry, my list, and then get the sorted list. Yep. So what's this function, what's this code going to do? It's going to ask for the first number, then the second number, then form a list, show us the unsorted list, then sort it and show us the sorted list. Okay, let's see. First number, let me give a larger number and a smaller number, then run it. As you can see, the first list is the unsorted one. It sorts it and prints out the sorted list back to us. Any final questions on how functions are functioning, how you write functions, how you try stuff? I mean, most of the stuff, as you have seen, is found out by just trying. I've made mistakes here. I just look at the error, correct it, and just run it again. If I'm not sure about something, I just try it again and find out. And this is how you should, I mean, they call it hands-on experience, right? You have to just try certain things and find out how they are done. Okay, good. I hope I haven't taken all your energy away. I hope you're as psyched as you started this class today. So with that note, if there are no questions on the chat, we can end today's class, I think. Yeah.
Function you were talking about make this job a lot easier.
Append function. This is how you use it. In 1 second, I'm giving you the append function. So you could have, instead of doing this, you could have done something like this. I think it should work like, actually, I have to check the exact code, but it should be something along these lines. Again, you cast the input from user to integer. You write here, like, and again, enter number, etc. And either, I think it should be, it might be here, I have to check exact code, but it might be something like this, mylist.append, and then this whole thing. It might be like this, I'm not 100% sure about the exact. Is it right? Okay, let's run it. So it should be asking for 3 numbers now. First one is a large number, the second one is a smaller number, third one is even a smaller number. Yeah, it worked. Yeah, this is how append function is working now. Mylist.append, and then the whole piece for taking an input from the user. And gave us the expected result. You have the chance to play with all these functions, etc. in your lab sessions. Let me see, ask one more time if you have any questions regarding the stuff that we have done here.
So when I use append, I don't need those dummy numbers, right?
Yep, right. Because as you can see, the list had already 2 numbers only, but we could add a third number by using the append function. Okay. The course record will be uploaded at some point. That's somebody's asking that. Can we access? Yeah, the recording will be accessible at some point. I don't know when, but I'll make it accessible sooner than later. So
I'm sorry.
Sorry.
Some students asked about the quiz.
So the quiz, what was our final decision, Tayyip Hocam, about the quiz? We are not giving the quiz. We can give it? Okay. So the final decision is we can give the quiz is the final decision, guys. So no, I'm kidding. I think I will upload the quiz at 10 p.m. tonight when I reach home. It will be super simple, and I will give you time until tomorrow noon so that you can just write it in. It will probably take 15 minutes to complete it. Okay? I will upload it tonight at 10 p.m. Thank you, guys, and see you later. Take care. Bye-bye.
Thank you, John.
Bye, everyone. Thank you. I think I can just leave here.